if it was not a KC keynote, it would be Star Wars. Because look at this wonderful movie theater in which we are all sitting. I have never presented to a group standing in a movie theater. And the only tussle I have between my students and I is to decide who is the Yoda. So let me get started. That's okay. Yeah. So it is really an honor for me. It is the first time I'm coming to Norway, and I'm quite sure it is not the last time. And just in case John missed out on any of my introduction, knowing that there are some recruiter stalls outside, I thought I will put up my CV. Although my gut feeling is that they are not looking for professors, they are looking for people who can write machine learning. So I think our students have a better chance than our professors. But you can see I have a varied background. Yes, I look Indian because I am Indian, but the passport I am carrying is Australian. For 30 years before moving to University of South Florida, I was in Sydney, Australia. My family is still there, and when I talk with them, they are stunned to find out that we have got 20 plus hours of daylight. So my family and I are exactly on the opposite ends of the earth right now. And it is cold over there, but cold over there is really meaningless to all of you. So it's an enjoyable experience. Life itself is a very enjoyable experience. You can see I have done a bit of work in Rotary as well, and here I attended a Rotary meeting, and President Torkel was there, Kongsberg Rotary, and I also took Professor Orila with me and enjoyed that social outing. So that's my background. Yes, I did write 20 books, but my wife is not happy with it because she believes I should stop writing all these silly technical books and write Harry Potter. And that way she can travel business class or do some shopping that she wants to do. It is really data science that is taking off. And if I extend Majid's brilliant talk yesterday evening, I was telling him, Majid, you have ruined my keynote because you delivered my keynote yesterday night. So I had to go home and add some new slides to what he was saying. But I think students like these in your university and of course in my university, and also I am doing PhD supervision of a student in Western Sydney University. These students who are digging into data science, I believe, have a wonderful future. As this little slide says, it is the sexiest job of the 21st century. One of my favored author, Alvin Toffler, wrote this in about late 1970s, his book Third Wave. And he has written a few other books, Power Shift and Future Shock and so on. But in this particular book, he highlighted how we, the humans, have gone through 3 waves of revolution. So hunting to agriculture, agriculture to industry, and industry to information. And then Alvin Toffler is saying that not only are we going through these waves, but the rate at which we are changing is faster. So his theory, which I totally subscribe to, is that we are accelerating in terms of the change. And if he is true, which I believe he is, then the hunting to agriculture took 1,000+ years, agriculture to industry 100+ years, industry to information a few decades. So I wonder whether we have already gone through the fourth wave and perhaps even the fifth wave. And discussing it in a keynote is quite relevant because keynote is just a discussion of a key that will open up opportunities for all of us, especially younger folks. So, if I may use the words quantum computing, nanotechnology, big data, machine learning, artificial intelligence, it all falls under the fourth or the fifth wave. I wouldn't even want to label it because it is going so fast. Yesterday in the IOTA presentation, we all saw that there is a small car, auto car, that is being plugged in to generate its battery, recharge its battery. One modification I would have liked in that particular picture was, why is the car having a steering wheel? Because the generation after us, I'm an old man, the generation after us, and nobody is going to necessarily need a driver's license. For last 3 years, I've been in Florida, and there are people, professors who are doing research in the socio-cultural aspect of aging. And one of the nationally renowned professor, my colleague, Professor Kathy Black, her research was on the impact of taking the driving keys away from a 80-year-old person in Florida. And her research is brilliant in highlighting the fact that when you take the driver's license, when you take the driving keys away in a country like America, in a state like Florida, you can't even go and buy a bottle of milk, can't go to the movies, can't go to the restaurants, you are confined unless someone else helps you. And we have, of course, the IT folks, and I'm an IT person, are very proud to say that we have revolutionized the way people move through a concept like Uber, which doesn't own a single taxi, and of course Airbnb, which doesn't own a single hotel room, and so on. But those autonomous cars are going to change the quality of life of these people, and perhaps when my time comes to celebrate my 80th birthday, as we did the day before with some other folks over here. So it's for us to think what is going to happen and how technology is A, going to make it happen, and B, help us handle the change when that occurs. So the important question when we are talking about big data, which is the topic given to me, is how do we fathom, how do we ascertain what is big and what is not? And I gave a one-day workshop yesterday, and I've been talking about this quite a few places. And there is always this interesting question, is 500 terabytes big? Or is 1 petabyte very big or not big enough? And the context of that size of data is so important, because when I'm driving using Google Maps from Kongsberg to Oslo, I might be generating 2 megabytes, maybe. But if it is a jet plane flying across the Atlantic or Pacific, in one flight, 12 hours, it generates 1 petabyte of data. So let us stop saying what is big data, or let us stop saying what exact amount is big data, because it depends on the context. And therefore, this is one of my favorite slides, and some of you might have already seen it. This is big data. Look, 5 men, strong men, are required to push big data up on a truck. And I invite you to make a guess. The size of this big data, it is big, right? Any takers, except those who have seen this? Okay. And it's not a gigabyte, it is megabyte. So in 1956, and yesterday we had a brilliant keynote from IBM, and we listened to Watson and other wonderful things that IBM is doing. But in 1956, 5 megabyte was big. So in 1980s, when I started writing my COBOL code, I was very proud of the advancement in technologies when I could carry 1.44 megabyte on a floppy drive in my front pocket. And I have preserved some of those floppies because one day I think they will be vintage item. And if I can't write Harry Potter, I will sell those floppies in museums. So the first thing to remember to note is that there is no such thing as big data. It is really data in the context of what we are trying to do. Now, in terms of the growth or the explosion in terms of data, here is another interesting look at it. We find that if we have to really look at, where is my pointer? Okay. If we have to look at the amount of storage we need for the growing data, we find that somewhere if we reach yottabyte, we are going to need the data center the size of Rhode Island and Delaware together. The idea being that this ever-increasing growth or explosion of data cannot be absorbed and cannot be stored in the way we are used to storing it, which then opens up ideas such as biology and computing. Because I'm sure that the scientists who deal with this stuff tell me that my brain and your brain has 4 billion cells. So that means if I die and my brain is used for data storage, it can store at the most 4 billion cells, and I don't plan to die in any hurry. So maybe we use a goat's brain or a rat's brain or whatever it is. But I know some young PhD aspirants. In fact, I met one in Salt Lake City, and he was saying, I'm looking for a PhD supervisor, and I know these couple of guys, and I know that they are doing research in storing data in DNA. And if we are likely to store data in DNA, then the Rhode Island size may shrink to the size of a truck. I don't know whether that is good or bad. As a IT person, I'm simply stating the fact because all of us will start wondering what are we going to do with that data space. But then that is what we were wondering when megabytes became gigabytes, and we thought we don't need that much of data. Because since we have IBM in discussion here, wasn't it Mr. Watson who once upon a time famously said that there is a world market for 4 personal computers, 4 PCs? Maybe it is true because we are going down the curve now and we don't need PCs anymore. Now we are talking about a system engineering conference, right? KSEE. So what is a system? Typically, as I remember my lessons in system engineering, there is an input, there is some process, and there is an output. And I don't think conceptually a system has changed. Being an IT person, of course, I am interested in software systems, but I also understand and appreciate that there are other systems that may not necessarily be software. For example, running this conference is a system, and we have got input and a process happening and output, and there is not much software involved except PowerPoint. So this is my fundamental understanding of a system. And when I talk about big data, I want to talk about it in the context of a system. And if it is big data and machine learning, both together are going to do what? They will take some data. Maybe they will take a lot of data. They will process it, and then they will spew out an insight, a result, a bar chart, a pie chart, a audio signal, whatever it is, to help the user. So in my opinion, in all of this, the user is the key stakeholder, And many a times I find my brilliant students lose sight of the fact that they are not writing Python or Java for fun. They are writing it for a stakeholder, for a user. So that is really my starting pitch for why we need a approach to big data that is more than just lots of data and simply using logic to analyze that data. If you Google big data and strategies, you are most likely to come up with results that are either analytics or technologies. And I have done that multiple times, and I find that even those articles or case studies, use cases that are trying to say they are strategic are actually either analytical or technical. And I'll explain that a little bit more. But here I am trying to highlight the fact that strategies need to be something in addition to analytics and technologies. Why? Because that is the approach that is going to provide value to businesses, which is the focus of what I'm trying to do. This was a little survey done a while ago, 2012, and I do a fair bit of writing for Qatar. This is a Qatar article. And I enjoyed how various respondents considered big data, including and especially the last line, Hadoop. Now, just a quick question, how many of you are comfortable with the term Hadoop? If you can quickly raise your hand. Okay, only 3 or 4. Okay, so then let me take a little bit of time, just a few seconds, to explain what really is Hadoop. I will reach there in a couple of seconds, yes. So we are all comfortable with the fact that data is growing and we are having the opportunity to store data, and that we run out of that storage space and we have got more storage space created, and then DNA, and then there is also the research going on, or perhaps even completed, but I have not read the paper yet, that the spin of an atom can store data, which I believe is trinary, because a atom can spin clockwise, it will be 0, anti-clockwise is 1, and fuzzy will be 2. Now that is something way beyond my capacity of my atoms in my brain. But I do think that we reach that stage, it will be, phenomenal amount of storage. So while we continue to increase the storage, and some of us use cloud-based, backup, like my laptop is always backed up on Backblaze. Maybe some of you use some other backup mechanisms. For $60 a year, every bit of data that I have is backed up. And should I lose my laptop? I hope not. That is the biggest risk. I can lose my passport, not my laptop. I can pay $200 and get a hard disk shipped to me with every last bit of data. The question is, for a business like a bank or an airline, if they are backing petabytes of data, is that data of any value to these businesses? In fact, is my data of any value to me? I jokingly say nowadays when I take a photo, I don't say 1, 2, 3, I just take 3 photographs. One comes out good, the other 2 are dark data. And there are gigabytes, maybe half a terabyte of photographs I have taken that I may never access. So there was one guy who spent a lot of time to not only increasing the capacity to store data, but to also improve its analytical capabilities and its retrieval and its overall value to business. And his name is Doug Cuttings, and Doug is really attributed credited with creating a highly distributed architecture called HDFS, Hadoop Distributed File Structure, which has enabled Yahoo and later on Google, and I think now he's an independent guy, to come up with the mechanism that if you key in Bhuvan Unhelkar in Google, it will produce something. And it will also tell you that it took 0.00001 second to produce this result. So it is one thing to store large amount of data, and it is another thing to be able to retrieve that data within a fraction of a second and display it. And if you extend that to the businesses, obviously they want to be able to access this data as quickly as they can, which is Hadoop. Hadoop is not a acronym, but Dave Cutting's little kid was playing with a yellow stuffed elephant and was calling that elephant Hadoop, so he just named his whole technology Hadoop. And almost all distributed architectures, perhaps even the starting point for blockchain, but I don't want to go there right now because IoT is so much better now, right? Is really based on this distributed technology. And funnily, once he named it Hadoop and Hadoop was an elephant, all other Apache projects, there is Ambari and Scoop, and there are all projects named around elephants and pigs and so on. It's a interesting exercise to go on Apache Hadoop site and see the 30 odd projects that fall under Hadoop category. More than half of them are named around something to do with an elephant. Like Ambari, for example, is a project that deals with management of tools that are managing the data, something like that. And Ambari, as some of you might know, is that thing that is put on top of an elephant where the Mahout sits. And Mahout is another project. We live in a very interesting world. Like Google, for example. What is Google? It is neither an acronym, it is nor any meaningful word, and it is now the most popular word. It is now added to the dictionaries. So big data. 4 plus 1. Volume, velocity, variety, veracity are the 4 most popular ones which appear on this slide. Volume is understood, creating, including historical data. But velocity is even more interesting. So we've got in volume large data. In velocity, we have fast data. The speed matters. In variety, we have not only the transactional data, which in fact doesn't even qualify as big data, but we have got blogs, emails, all the likes on Facebook, and all the tweets, and you name it, unstructured. Then we also have audios and videos and machine sensor data. Machine sensor or machine generated data may still have some structure, but otherwise for most part it is clubbed under unstructured or semi-structured data. And the analysis that we have to do, I used to work in the 1990s for Dow Jones, and we used to we wrote an application called currency options. And the whole logic there was using Black-Scholes and binomial mathematical models to find out what will be Norwegian kroner versus Australian dollar versus US dollar versus British pound and so on. One of the most interesting things I learned there is that a news flash, a news item, has an impact on the way the currency is traded. So the brokers are continuously looking for what's happening. Did the President of the United States smile today? Or did the Prime Minister of Australia met with the King of Norway, or whatever it might be? And it will have an impact. Now, brokers would get up early in the morning and study these reports, newspaper reports. Imagine in today's age, if you have to go through 1,000 such blogs and reports in order to make sense. That's what the technologies of big data are trying to do. That they are helping us analyze and understand unstructured data. We could be writing emails to each other, And John over there is a gentle person, so he says, this conference was great. And I'm a strict guy, so I'm saying not bad. But actually, I mean, this conference is great. And we have to analyze those 2 emails and other 1,000 emails to figure out the sentiments of people here. That's what these technologies are doing. So text analytics, for example, Tableau, although forgive me if you like Tableau, but it's a very sophisticated visualization tool, more than analytical. But we get students and researchers to write code in RapidMiner, which is a recommended tool in my opinion for what we are trying to do. And the last, veracity, garbage in, garbage out. So it is better to control the data flow that is coming in order to improve the analytics. And then last and most important in my opinion is V for value. And unless we can find value in data, all data is dark data in my opinion. And if we are going to find more value, we need to look at more sources of data and very creative ways of using that data. And I have got some more thoughts on it as we go along. Time wise, another 15, 10 minutes. Okay. So the business challenge is V for value. And I put this up for 2 reasons. Platify is actually another company that I work with, that I partner with. It's out of Bangalore in India. And we have created a elastic platform to offer virtual labs in universities. But the other important bit to mention this is, when we talk about V for value, if it is a large bank or an airline or a hospital or a telecom company that I have worked with, they have enough resources to create their own big data installation, their own Hadoop installation, or even something like MongoDB. Not that it needs a lot of cost, but it does need a lot of effort to make it valuable. But if you look at small businesses, and I do research in Florida, near Sarasota in particular, and Tampa and Miami, there are thousands of restaurants, coffee shops, dentist surgeries, who are all small businesses. Invariably, they are running their business in Excel or at the most a small accounting package so that they can report. They have no idea about big data. They have heard about it. They don't know what machine learning means. They are keen to know. And if we can be of any help to them, they would like us to help. So what is the best way to do that? The best way to provide value to small businesses is to have cloud analytics. Provide analytics on the cloud, and they pay using IOTA, I presume. Every information a restaurant owner wants to know if tomorrow they are likely to receive 120 guests coming in, and therefore should they go and hire 2 temporary helping hands. Now that is very valuable for a restaurant owner. And small business owners are running all this analytics in their brain. They go to sleep and they know exactly what they should be doing. But can they be provided additional information through something like weather data? Most weather data is made available publicly online. You can use those APIs, plug them in your analytics. These guys have not even have a website, but mostly they are interested in TripAdvisor, because TripAdvisor provides feedback on how the restaurant experience. Pepe's Pizza across the bridge is not bad, for example. So that's my thoughts over. Okay, now what have I got? I'll give you very quickly some case studies. I don't know why we call them use cases. I'm a UML guy. I was there when UML was released in 96 and 97, and the Three Amigos and Jakobsen and Rumbag and Booch. And that was when Jakobsen called something a use case. And nowadays, everywhere I go, a case study is called a use case. But a use case is that elliptical thing that represents an interaction between blah, blah, blah. Okay, so here are some examples. Southwest. This airline is unique and competes with American, Delta, and United, because through detailed, in-depth, deep analytics, they discovered that the quicker they can turn their planes around, the more money they will make. So there are three things they have done. They only use satellite airports, in fact, four things. They have only one set of fleet, so their staff is changeable, 737, nothing else. They provide two free check-in bags, so the passengers are not carrying their bags with them and spending time putting them up in the overhead bins. And they have removed seating numbers. So group A goes in and finds the seat that they like, and then the people with strollers and children go in, and then B and C. So a strategic decision, in my opinion. UPS found out that if they chart their path where the trucks are only taking right turns, it will be faster, although not necessarily shorter. So they have implemented that, and no doors for the driver, and that reduces the time. It is a strategic decision, in my opinion. This is one of my favorite ones. 200 billion records were crunched in order to recommend whether the flight from Oslo to Chicago day after tomorrow will be $300 or 350. And on the recommendation of 300, if I buy it and day after tomorrow the price goes to 250, he was refunding $50. So Mr. Bill Gates found it worth $110 million, purchased it, incorporated in Bing, and now I think it is shut down. I don't mind if my tools are shut down if I get paid $110 million, right? You can use this. DNA analysis, just a swab of saliva and a $99 check. And I believe Steve Jobs had spent a few $1 million trying to go ahead of his horrible pancreatic cancer. Rather sad story over there. But he could have succeeded if he had started a few months before he did. That is the story I have read. Correlating traffic jams in London with growth in economy is a fascinating big data analytics project. If there are more people driving, then there are more traffic jams. And if there are more traffic jams, that means the economy is likely to go up. One thing to note with big data is it is correlation and not causation. Analytics are not able to answer why such a thing is happening. But with something like 100 million cars data, we are pretty much able to say with, say, 75, 80, 90% confidence that yes, it will happen. So Dr. James Ricard related the prices of puts, calls and puts, prices of puts, which is the right to sell a share of American and United, 3, 2, and 1 day before the 9/11 disaster. And based on his brilliant analytical work, big data, in this book, Death of Money, there are chapters around his analytical work on showing how a stock market and a terrorist event were related. And he was able to predict the London tube bombings without being able to say that it is going to happen in a tube. But he was able to get the security network up and running 6 hours before the event. The charm of big data. And then US elections, I won't go into that. This is very simply Amazon's long tail marketing. So if person A buys a product and person B buys the product, or in this case X1 and X3, and they show some sort of relationship like the same postcode, then if X1 buys some bizarre product like meditations by Osho, then let's recommend that to X3. And that has actually happened with my dear friend Professor Anurag Agarwal and I. It's very funny that occasionally I can say, Anurag, did you buy a shaving razor on Amazon last week? And he says, you got an ad, right, from Amazon saying this is a great shaving razor. That's long tail marketing by Amazon. It's fascinating. Okay, I'm left with now 3 minutes. And the whole reason I came here was to present my big data framework. So I'm going to be available after that. 5 minutes.
My job to manage that, don't worry. You carry on and do yours.
Okay, but I do want to highlight what I have done, what is my contribution, and it started about 5.5, 6 years ago, and now it is in a book form. There are some books here. I'm not a very good marketing person, but my publisher has said you should always show the book. So this is Big Data Framework for Agile Business, and then Art of Agile Practice in case you are interested. And should I also show my UML book, which is my textbook? None of them are Harry Potter, But one thing they will do, they will, if you have a problem going off to sleep at night, I can guarantee 95% money back guarantee. It's much cheaper than going to a doctor and saying, prescribe me some pills, Also, I'm very happy to share this presentation. So I see some of you are taking pictures. You're welcome to take pictures, but the presentation is available. It's with John, and you are more than happy to take it. So, Big Data Framework for Agile Business. Why do I need a strategy? Because otherwise I have got data and machine learning and AI and Java and C++ and MongoDB and all these wonderful things. And I worked with banks and airlines, and I know that they have got a special cell where all the big brains, the great brains, are experimenting with big data. But then it turns out like this. So my argument has been, at least 6 years ago, that we need a strategic approach with a framework. And that's the framework I'm going to show. I can't figure out which direction this car is going to go, or whether this is actually a car or not. So up there is a technical view, typically Hadoop based, NoSQL database based. After that is the analytical view, but then I am looking at V for value through a more strategic view. And of the many things here, on the left you will find there is a maturity level, 5 levels, and I have created that level similar to CMM, capability maturity model, but in terms of big data, how mature is the organization, and then of course leadership and all these wonderful thoughts around it. Again, a more holistic approach, strategic approach. Okay, I am rushing, but you are saying I can go a little bit slow.
Recalibrate.
Recalibrate, reduce my Indian accent a little bit. When I'm charged up, I speak in Indian English, which I am very comfortable with. Then I move to Australian English, which is not really English, right? I mean, it's a good day, mate. You came here to die? No, I didn't come here to die. 30 years of wonderful time. My children, they look Indian, and when they open their mouth, everybody is confused because they speak good Australian English, Aussie. So in terms of starting with the strategic direction with big data, this is a strategic cube, and it is highlighting either the business can try external opportunities or try and reduce or optimize internal processes, or reduce risk, or handle the environment, or a mix of these. For example, XPO, which is a very big logistic and supply chain company, is not trying to increase its customers, not trying to go out and improve its market position. It already has a good market position. What it is trying to use big data for is to optimize its internal processes so that the profit margin is bigger. If we look at something like, if we look at most American companies, now with GDPR, which is applicable to Europe, any American company dealing with Europe has to comply with GDPR. So there is a phenomenal amount of governance, risk and compliance requirements. And big data storage, retrieval, analytics can help in improving the compliance requirements or reducing the cost of compliance. So, okay, this is just an aside. I have, with lots of discussions with colleagues, I have created a big data manifesto. If you like it, I'll send it out anyway. If you like it, you can say, yes, I subscribe to it. So I have a couple of hundred people saying, yes, this makes sense, because this provides guidance to the industry in terms of how to go about applying big data. Mainly because big data can be unethical. For example, by doing detailed machine learning based analytics, a insurance company can figure out Bhuvan Unhelkar, 50 plus years of age, vegetarian, yes, but eating lots of wonderful sugar and oil, is likely to be diabetic. So let's make sure that we don't insure his medical program for anything to do with diabetes. This is just an example. On a slightly serious note, it is, and there are use cases out there that police department is advised that a crime is likely to occur here. So send your police cars in this area. Now that can be unethical if only certain areas are targeted. So things like that. So we need a manifesto to provide some ethical guidance. Okay, um, let me zoom through this, but let's look at what we need when we talk about a big data framework. We need values, we need to define the values, then we need to define the roles like data scientists, then the building blocks, there are 5 building blocks, then the artifacts. It is a full-on framework which can be customized. Then what kind of business it is? Is it a big, small, medium? Is it product? Is it service? It is global? Is it local? Those parameters are going to drive how we apply big data. And then of course we can use some practices. We need a project plan, so that is the 12-lane adoption process, the strategy cube that I showed you, and the manifesto. Now this becomes really very complicated. And I've spent at least 2 years working on it. So I've got a simpler diagram for you. That's this. This is easy. This is very convincing because nobody can figure out what is in this. On a more serious note, the headings that I showed you in the previous diagram are put here in more detail. And one of the key advantage is the building blocks. So this is for a large business, especially a large business, trying to adopt big data. And so something like predictive and prescriptive and descriptive analytics is a small triangle in the second building block. If we look at the fourth building block, that is enterprise architecture. And funnily, many big data initiatives are thinking about enterprise architecture as an afterthought, which is not a good idea. So I have put there Zachman framework, which is my favorite architecture, but TOGAF is there and a few other enterprise architecture. The last building block is quality and people. For example, we need a framework to upskill people. So we need to figure out where they are. And there is a 7-level framework called SIFIA, Skills Framework for Information Age. And I have extended that framework and applied it for big data skills. Another example, nobody is talking about business process modeling when it comes to big data, because big data is treated as analytics. But if you see the biggest area where value is generated is when you create a formal process model using BPMN or activity diagrams and optimize that using analytics. So those are the kind of things I have put here: SWOT analysis, the 12-lane project plan, and I am on the last slide. You were showing me 1 minute. So I hope I have managed it in time. Let me just quickly put some references. All academics have to put references. My articles, the journal articles, this I had guest edited Trends in Big Data Technology. And just in the process of guest editing, I came across interesting things like fog computing. Have you heard of fog computing? You know, cloud is up there in the sky and the fog is down there on the ground. So if you have got servers that are local and that are handling only a local group of IoT devices, it's called fog computing. I learned those kind of things. These are some of my articles in Qatar. I can make some of them available. This is my work in Agile, and I am a professional Scrum Master, and I'm right now working on a book titled Psychology of Agile, based on a couple of reports that I had put together. Reference for you, you can download this freely available report, just 3 or 4 pages. But this is actually a very exhaustive report, and exhausting as well. But it's an old report. The contents have changed, but the headings are very relevant to a business trying to adopt big data. So these are some of the highlights of that report. And I am very, very thankful to all of you, thankful to entire Norway, and then of course in particular to John and Orilla and everybody who have made me feel so welcome. Thank you very much.
Thank you so much, Bhuvan. Thank you. I think I would just like to check if there are any questions.